Assume we have only 3 neurons in the output layer with the softmax activation function. That is, only in this network we have softmax activation function. That is classification problem. Only assume 3 neurons. It is mentioned in the question. Suppose that the weights are initialized as follows. That is W1, W2, W3 all are equal. So W1, W2, W3 is a matrix of size 3 cross 3 given in the question. And A is a vector. A is a pre-activation vector. So this one A1, A2 and A3. A1, A2, A3 are given in the question. And Y is also given in the question. Y is a true label. Use the cross entropy laws and compute the gradient of W10, that is gradient of W10 of W3. That is, they are asking delta W310. That is, they are asking the gradient of delta W3 using the cross entropy laws. This question is related to back propagation of the neural network. So for this question, so here we know x0 is input, xi is the input, is the h0. To h0 equal to 101 is given. So this is the first hidden layer. This one is first hidden layer, that is hidden layer 1. This is the hidden layer 2. This is output layer OL. This is the input layer IL. So A1, A2, A3 are the pre-activations of the layers. H1, H2, H3 are the activation functions. So the size of the activation functions, that is H1, H2, H3, size of H1, H2, H3 are, the sizes are, these are generally vectors of size, how many neurons in that layer. In H1 layer there are 3 neurons, 3 cross 1. So all are equal. H2 layer also 3 neurons, 3 1, and output layer H3. So here in the output layer H3 is y hat also. H3 is y hat, that is output. H3 is y hat. H3 equal to softmax of A3. H3 is output, which is y hat also, and H3 is softmax of A3. And H2 equals to this one. This layer sigmoid are using, that is sigmoid of A2. H1 equal to sigmoid of A1. And we know that AL minus 1 equal to WL minus 1, HL minus 2. In the layer, L represents the layer, plus BL minus 1. That is, L is the layer. L represents the layer. We want A3, right? A3 equals to W3 H2 plus B3. In the question they given bias is 0, that is B3 is 0. So A2 equals to W2 H1. So B2 is also 0. B2, B3, all our bias sizes are same as the A3 sizes. Next A1 equals to W1 H0 plus B1 input layer, there is no bias. You have to remember these equations, it will help to solve the question. So they are asking delta W30. Delta W310 equal to, so back propagation move in this direction. So first we have to differentiation with respect to A3, that equals to dou L by, in this layer we have loss, dou L represents the loss using cross entropy loss. They mentioned in the question, dou L by dou A3 into dou A3 by dou W310. This you have to remember, dou L by dou A3. So here in this last layer L is there, you can go back, that is L is in terms of A3, that is differentiation of partial differentiation with respect to A3. Next A3 with respect to weights, here weight is there, right, W310. So that is from the relation we know dou L by dou A3 equals to y hat minus y hat minus y, or you can write minus of y minus y hat also. Is this also okay? There is a derivation in the lectures. So dou L by dou A3, that is differentiation of loss with respect to pre-activation function is y hat minus y, this value, and dou A3 by dou W3 we have to find y hat minus y. So y hat equals to, y hat is, so here in this layer output, right, in this layer output is y hat, this one, y hat equals to H3 equals to H3 is this one, softmax of A3, softmax of A3. We know A3 is given in the question and all these values are same, approximately 3.84, 3.82, 3.82, so all are same. So y hat equals to softmax of A3 equals to 3.84, 3.82, 3.82. That equals to, how do we write softmax? E power 3.84 by 3.84 plus 3.82 plus e power 3.82. Same for this value, e power 3.82 by e power 3.84 plus e power 3.82 plus e power 3.82. Next for this value, e power 3.82 divided by e power 3.84 plus e power 3.82 plus e power 3.82. All these values are same because all these values are approximately same. That is 3 cross 1. So its value is approximately, for this value is, for example, A. This value are also say A by 3A. A cancelled and 1 by 3. Same, all these values are approximately same. That is each value is 1 by 3 and 1 by 3. Otherwise you can remember like this, the size is also becomes denominator. 1 by 3, 1 by 3 and 1 by 3. This is the y hat. So we have to find y hat minus ya. So that is y hat minus y equal to true value is given in the question. That is 1 by 3 minus 1, 1 by 3 minus 0, 1 by 3 minus 0. That equals to minus 2 by 3. Minus 2 by 3, 1 by 3 and 1 by 3. So we solved this value. So this value is we got. So this is important. Next we find this value dou A3 by dou W3. So that is dou A3 by dou W310. W310. There are 3 neurons in each layer. So input layer, hidden layer 1, hidden layer 2 and output layer. In how to write W3 matrix. So W3 matrix equals to W3 matrix size is 3 cross 3. So W3 size matrix. W3 is number of neurons. First we write this one output layer. There are 3 neurons. 1, 2, 3. That is 3 cross. How many neurons in this? In this layer input. W3 matrix. These are the input. This layer is output. This layer is input. So 1, 2, 3. That is 3 cross 3 matrix. W3 matrix, right? So in every layer, this layer, this one is first neuron. All row values are same. Wait, I will tell. That is W300, W301, W302, W3, W3, 310, 20, 21, W3 11, W3 22, 12. See, in the first 3 represents in W300, for example, is this value 3 represents the third layer, that is in this layer, third layer, and this next 0 represents weights, that is weights coming to 0th neuron, that is first neuron. So this is the 0th neuron, first neuron and the second neuron. In this question they starting from 0, not 1. So 0th, this is the 0th neuron, first neuron and second neuron. So all the weights coming to this neuron, 0th neuron, all the weights, that is W30, W3010. This is also 0, 1 second neuron. So like that, W3, that is the weights coming to 0th neuron in the output layer. This 0 represents the weights from which input layer, that is input layer, previous layer, this layer, H2 layer. This is HL2, hidden layer 2 layer input numbers. So that is W301, W302, W302, like this. So for example, so in this row, complete in the matrix, weight matrix, complete row, 30 is the common, 0 is same, that is fixed. 3 is third layer and 0 represents the first neuron. All the weights coming to the first neuron, this neuron, 0th neuron. and all the weights coming to the second neuron represented with W3 third layer, first all the weights coming to the first neuron 3 1, that is in the next layer 3 1 is common. In the next layer W3 2 is common, 3 2 third layer, and all the weights coming to the last neuron, that is this neuron second neuron, all the weights coming to this neuron, that is row. In the row W3 0 is common in first row 1, and W3 1 in row 2, row 1 row 2, and W3 3 in row 3, whereas in column first neuron is common, but the way here 0 1 2 3 neurons, incoming neurons are changed. This is the weight matrix W3. We have to find the W3 1 0, that is dou A3 by dou W3, that is the partial differentiation of the pre-activation function with respect to weight. Generally A3 is in terms of A3 is in terms of W2 H1 plus B2, W2 H1 plus B2, W3 H2 plus B3 is 0, is given, bias is 0, so this value becomes 0. So A3 equals to W3 H2. So we want dou A3 by dou W3, that equal differentiation with respect to this W3 we get H2, but in this question we used H2 transpose. Why? Because of dimensions, to match the dimensions H2 transform, that is delta W310 equals to dou L by dou A3 into dou A3 by dou W310. This value is y hat minus y, that is there is a derivation, the differentiation of the loss function with respect to A3 pre-activation function is y hat minus y, and this value is H2 transpose. So delta W310 value is y hat minus y times H2 transpose. Generally for 3 layers are given, it is very hard when 4 layers are given in the question. So generally 3 layers are given in problems. You have to remember. If you remember, it is easy to solve the questions. It take lot of time in the examination, during the examination. So remember, if possible, y hat minus y times H2 transpose. In the same way, delta W210 means W2 in the second layer, that is back propagation going to from output layer to third layer to second layer. So this formula is W3 transpose. So increase one value plus 1 here, W2 W3 transpose. So y hat minus y had mod product of H2 times 1 minus H2 had mod product of H1 transpose. If possible, you remember y hat minus y value, that is y hat minus y equals to minus 2 by 3, this value minus 2 by 3 1 by 3 1 by 3. So y hat minus y value equals to minus 2 by 3 1 by 3 and 1 by 3. So we want H2. So H2 is the activation function. H2 is the activation function in the second hidden layer, that is this is output layer HL2 A2 H2, A3 and H3. So all are sigmoid functions. So H2 equals to sigmoid of A2. So that is sigmoid of, we don't know A2. We know A2 is given in the question. 3.2 to 3.92. Okay, that is sigmoid of 3.2 to 3.92, 3.22. So sigmoid function is e power minus sigmoid function, sigmoid of z equals to 1 by 1 plus e power minus z. So you have to find these values. That is H2 equals to 1 by 1 plus e power minus 3.22. 1 by 1 plus e power minus 2.92. 1 by 1 plus e power minus 3.22. That is approximately equals to 0.96, 0.94, 0.96. These values. So that is delta W310 equals to minus 2 by 3, 1 by 3 and 1 by 3 times. So this is 3 cross 1. If we write only H2 also 3 cross 1. So multiplication, matrix multiplication is not possible. So we use, because of that, dimensions to match H2 transpose. That is 0.96, 0.94, 0.96 transpose. In this question, in this question they gave scaled sigmoid function, that is 2 by 1 plus e power minus z. So not 1 here, 2, you have to multiply with 2. So 2 by 1.92 H2 value 1.92. This value is also same, 1.92 and 2.92 together. 0 minus 2.92 e power value plus 1 inverse 0.94 times 2, that equal 1.89. So these are the H2 values. So y hat minus y times H2 transpose equal to, this is sigmoid. What is the problem in this question means, use this scaled sigmoid function, that is 1.92 minus 2 by 3, 1 by 3, 1 by 3 times 1.92, 1.89, 1.92. Thank you for watching.